The first question is about the comments on the histogram. You can see the data file in SPSS, and I'm just demonstrating descriptive explore. In the descriptive explore, already the quantitative variable, which is salary, is selected. So you have to pick the dependent variable. And if you want to use the factor variable, then you can choose factor variable college here. If you want to remove that variable, factor variable, so you can remove the variable from the second button. So salary is a single variable I have chosen. In the statistics segment, descriptive, outlier, percentile, you can have these options, right? Suppose I am going to place descriptive and percentiles. Percentile will give us a like quartiles, deciles, and some factors. It will be in the output. So click on the continue, and in the plot segment, normality plot, stem and leaf, box plot, stem and leaf, and normality plot. Histogram I chosen. Now click on the continue, click on the OK. So we will have the results. The descriptive results, 100% observations are correct, means no missing numbers we have. This first table is indicating that. Missing numbers, there
Sir,
is
your
no.
screen is frozen.
Okay. The missing numbers are not there, though we can have zero missing numbers. 100% observations are available to us. This table, I already described this table: sample mean, trim mean, the median, standard deviation. These numbers are here. So you have to comment for the
Sir, sir, if there is missing values, I mean, usko
Okay, if there is a missing value, then there are the two options. One option is you can remove the missing numbers by just clicking the option analyze, descriptive, explore, and in the options, we have two options. One option is exclude cases listwise, exclude cases pairwise. By default, exclude cases listwise, but that better option is the exclude cases pairwise. As I told you, if we have the missing numbers in only of those variable which are included in my analysis, then that rows will be eliminated and will not take part in the specific model. If we have list wise, means if there is a missing numbers in the variable which we are not using in the specific analysis, then still that case will be eliminated and will not take the part. So exclude cases pairwise is a better option. So this is one option. Second one thing that you can do is you can impute the missing numbers. Imputation, I told earlier, imputation is what? Imputation is a process of finding imputation or impute. तो
फिर उसके
finding
ना यही करते हैं कि हम यहाँ पर तो एवरेज होता है तो उसको हम पुट इन कर देते हैं, तो वो मतलब एसपीएसएस में कैसे होगा?
mean imputation or by median imputation, whatever you can choose, because mean is affected by the extreme numbers while the median does not affected by the extreme numbers. The better option is to have a median imputation. In one case, suppose I have here two colleges in the data, college 1 and college 2. Suppose my missing number is in college number 1. To take the mean of the observations of college number 1 and then replace the missing numbers by the mean of the college number 1. If the missing numbers found in the college number 2, then you have to take the mean of the college number 2, trim mean of the college number 2, and impute the missing numbers of the that specific college by the mean of that. So respective mean is another better option. Instead of taking or imputing by the overall mean of the data, you can choose the mean of a specific segment of the data. Suppose we have a male and female in the data, and the missing numbers found in the segment of male, then use the mean of the male for that, right? The second question is, how can we impute them, or how can we place them um, in the data file. So I am just demonstrating this, but I am first covering the question of one student, how histogram is, suppose my histogram is like this. We have a smaller number, then a higher number, then gradually we have a smaller number. This is called positive skewed distribution. If my histogram is like this, we have a higher number, then gradually it is in downward position, then it is called as a negative skewed distribution or a symmetrical distribution. So these are the comments related with the shape of the distribution. But in the case that we have in the data file right now, I'm going to demonstrate the result and continue. And okay, so you can see that in the explore segment, the data is here, and the mean, the median, the trim mean, the variance, the range, interquartile, and all these numbers are here. This is the table which I'm using first time. The one thing is, what is this 25 percentile? So this is basically the Q1, first quartile, because quartile is a value on which the 25% observation will be on the left of that, and 75% observation will be on the left of that. So this is percentile 75 we have here. So now 99 is the third value of the third quartile, and 58.90 is the value of the first quartile. So how you have to use these two values for removing the outlier? That next question is, so we have to put a formula Q1 minus 1.5 times interquartile range IQR, and Q3 plus 1.5 times of IQR. So you have to retain these numbers, the numbers in between these two limits. So these numbers are the data which is known as not an outlier. So the data below this number is included in the outlier, and the number above this number is to be used as a right side outlier, or the extreme high outlier. This is the extreme low outliers. So this is the formula that we have to implement. But your question is a valid question, how we have to implement this formula into the SPSS. So I'm demonstrating that, but by looking at the result first, then I will take a decision कि ये इसकी ज़रूरत भी है या नहीं है. Now in my
फर्स्ट और
case,
थर्ड क्वार्टाइल ही यूज करना होता है हमेशा.
फर्स्ट और थर्ड क्वार्टाइल यूज करना होता है, ठीक है. Now in this case, the p values of Kolmogorov and Smirnov both are very small, so the h naught of normality is rejected. The data is not normal. Normal data is h naught, and not normal data is h1. So in the both cases, the h1s are true. So we call it as a significant Kolmogorov test and significant Shapiro test. Significant means the h1 is true. So
Sir,
the data is not normal with respect to these two tests. Yes, question please.
so I have a question regarding imputation. In imputation, we will use the trimmed mean to replace the values.
Yes. Trim mean is basically the mean which is computed by after eliminating the outliers or extreme numbers from the data. So after eliminating the extreme numbers, so we can use the trim mean for the purpose of imputation. Achha, now the data in this case is looking as we have an outlier of 65 here, right? So this is outlier 65. So there are the two cases. One is 65, case number 65. I can eliminate it by myself in the data file. So you can see that this 65 is basically this one. I purposely added this 600 into the data. That was not actually included in the data earlier, but I purposely included this to make the data not normal. If I remove this number by manual, I'm just clearing this. And after clearing this, and again, I am putting all of these things, explore and descriptive, with the salary variable without including the factor. Now you can see that the Kolmogorov test is 0.2, which is insignificant, and Shapiro is also insignificant, means the data is now normal with respect to the salary variable, and without including the factor variable, which is college. So you can see that this graph is in the linear pattern. Histogram is also in the
Screen is
But the
frozen.
output screen is not visible.
okay. Now you can see that the sig values for the Kolmogorov and Smirnov after eliminating that 600. Now 0.2 and 0.45 means the both of the sig values are insignificant. So means the data is normal in the salary variable. Now histogram is also be symmetric, and this is very better line which is indicating in the PP plot that the data is normally distributed, and box plot is also have an indication of normality. So this was done manually, but how can we do it with the help of formulas? I am demonstrating this. Now click on here, and again I am placing the 600 salary, or 680 is the salary in 2. It is in college number 2. The teacher is in the college number 2, and the salary is 680. After including this 680, the data becomes uh, not normal. Now analyze, descriptive, explore, and now you can see that all the p-values become 0. Now you can see the output again. All the p-values are 0, indicating that now the test is significant, means data is not normal. And this graph is due to this one segment, which is 600 and something. You can see that the data is not normal, because now it is extremely right skewed. And this is an indication of an outlier in a probability plot, because all of the numbers are in a straight line, but this is the single number which is outside the pattern of the probability plot. So you can see that this is a not normal, or a outlier we have, significant outlier we have. That is significant outlier we have in the graph. But if I eliminated this, so you can see that the graph is perfectly normal. So how can we do that? By the help of formula. That is the second question. So just click on transform, not transform, analyze. Now click on transform, analyze, not data. That is the option, data. In the data, click on select cases. Okay, select cases is the option, means we want to select the specific cases. The by default it is by default
So
it
we
is
can,
by
sir,
default.
can you repeat the steps, because the screen was frozen. We couldn't
Okay,
follow.
okay, I just clicked on transform, and not transform, data. That was the option in data. Can you see the data menu here?
Yes, sir.
Yes, sir.
Okay. The second last option is select cases. Okay. Split file, select cases, weight cases. Weight cases is for group data, frequency table. So most of the time in SPSS we have ungrouped data, but if we have a frequency distribution or a probability distribution, then we can use weight cases. So I'm not going to the weight cases right now, but select cases and split file. Split file means we want to split the file into two segments. Suppose I want to split the file for college number 1 and college number 2 separately. So I can use this option, split file. But the middle option is select cases. Select cases means I want to select only the specific rows. If I want to select only the specific rows, so this just click on the select cases. By default, it is all cases. By default, it is all cases, but you can have if condition here. Now, by default, it is all cases, means all cases are in use, but I want to put the specific cases, or I want to choose a random sample. The third option is a very important option. Suppose I have a 100,000 observation here in this data file, and I want to pick the 10% randomly from them. So this third option I can use for that. But second option is important, and we have to put a condition here. If what the by default it is college 1 and college 2, or this is college 1 or college 2, I am not placing the filter. This is called filter. I'm not placing the filter with respect to the college 1 or college 2. I want to place the filter with respect to salary. So I want to eliminate the formula. Just click salary. Salary is greater than how much and lesser than how much. Suppose I want to pick a very simple formula. Salary is less than 500. So you can see that this number will automatically be deleted if I use this formula. Salary is less than 500, then this formula will be, this number will be eliminated by default. But I'm nothing doing here, just only this function. Salary is less than 500. So I select the cases in which the salary is smaller than 680. So now continue. Okay. So you can see in my data file, in my data file, only the one case you can see it is cutted. It is 65 case number. In the case number 65, you can see that there is a cut on the left side. Means this will not participate in any of the further model or further anything you are implementing. Suppose I am going to implement the same test of normality, descriptive, explore.
If we have both minimum and maximum outlier.
I'm just going to move next. So now you can see that that number is eliminated. That number in the output, it is not there. That number is eliminated. Now your graph is very linear, histogram is linear. So very simple formula it was. That number exists in the data file, but not play the part in the descriptive explore, right? Whatever the command I will issue now, that 680 will not involve and will not participate in the any function. So that is assumed as eliminated, but not physically eliminated. It is eliminated virtually. We can, anytime we can retain that number into the data file. But the second question is, how can we remove the minima or maxima, both sides if we have? So I am just placing one more number here in the salary variable, and that number is 20, salary 20. So you can see that the salary 20.
Sir, screen change.
The screen is not showing.
Now you can see that one more number is 20, and I'm just going to put the both sides of the number to eliminate. The select cases, in the select cases, if salary is less than 500 and or salary is greater than what number that I put, suppose 50, because I think I put is greater than 50. Now you can see this formula, and think it's not working correctly. I may put an error. That error is what? Less than 500, and instead of or, this was the or symbol. So you have to place the and symbol. And symbol is this, or symbol is this. This was the or symbol, this is the and symbol. So once you have to place the and symbol, salary is greater than 50 and salary is smaller than.
So wouldn't we use or? Because in either case, if it would be either less than 500 or
Salary
greater.
is greater than 50 and salary. No, I think and is better. And I think and is the appropriate number.
Okay.
In the data file, now you can see some numbers are cutted. What that numbers are? This is 20 eliminated. This is 680. It is also eliminated. 31 because I put the number 40 or 50. So it's smaller than 40 or 50, something is eliminated. So this is eliminated. This is 40 eliminated. So you can place the both sides of the truncation. Now another thing is, how can we implement the Q3 or Q1? How can we implement that? So that can be implemented by just looking at the few results from the previous output. What was the previous output? Now I am just, first thing, I am just removing all filters. Data is select cases, all cases, means I have removed the filters. Now these filters are removed. Now all cases are included. This is the number which is included. This is also a number. And there is a one more column here. I am just removing that column, filter column. Now I want to put Q3 plus or Q3 minus before going to implement the Q1 minus or Q3 plus. To go to the analyze, descriptive, explore, and in the statistics percentiles, right? And okay, because I want to know the percentiles of this data set. The percentile is 57, 25th percentile is 57, and 99 is the other one.
Screen change कर दें.
Okay. Now this is 57, 25 percentile, which is quartile 1. This is quartile 1, Q1. And this is Q3, quartile 3. So just remember these two numbers, 99.6 and 57.7. These two numbers, I am just going to implement a formula in between these two numbers. I should have to place.
So which row do we have to consider for the values?
Weighted average. Average is the value that we have to consider. This is the value. Salary and 57.7 and 57.9. It is 99.5, and very slight difference in among these two. You can use any of the numbers because they are approximately equal in numbers. Now I am going to place these two formulas. One formula is data, select cases, and condition. And I am going to place a condition. What condition is Q1 minus, and the value of Q1 was 57.7. So 57.7 minus 1.5 times of IQR. And IQR is how much? IQR is 99.6 minus 57.7. So this is, and I have to keep the numbers of salary, and the same formula I have to copy on the right side. Control C and Control V. but we have to, one thing which I did error, double minus sign. You have to place a single minus sign, and this number is a Q1. You have to place a Q3 here, 99.6 and 6, and instead of minus we have a plus on the right side. 1.5 times of IQR is same. So this is the IQR. Can you see the formula which I am typing?
Yes, sir.
Yes, sir.
This is the IQR. This is 1.5 times IQR, and it is added into the value of Q3. And this is the salary variable which we want to place the filter on that. And this is Q1 minus 1.5 times of interquartile range. So I'm just click OK and continue and place OK. Now the data, you can see nothing is eliminated. Nothing is eliminated. The reason is what? Now explore.
सर आउटपुट पे लगाओ, डाटा पे लगाओ, कहीं भी लगाओ, दोनों पे हो जाता है.
आउटपुट पे कौन सा आउटपुट?
अभी हमने फॉर्मूला जो लगाया वो आउटपुट वाली स्क्रीन के डाटा पे लगाया, उससे भी हो जाता है.
नहीं, वो एक ही बात है, उसमें कोई मैटर नहीं करता. वो आउटपुट पे लगाएं आप या डायरेक्ट लगाएं आप, ये मैटर नहीं करता. लेकिन वो या तो क्वार्टाइल की वैल्यूज सही नहीं है, उसकी वजह से वो सही नहीं आया. क्वार्टाइल की जो वैल्यूज मैं वहाँ देख रहा हूँ, इसका मतलब है या तो वो वैल्यूज एक्चुअली वो नहीं है जो कि होनी क्वार्टाइल्स की हैं.
सर हमने जैसे लास्ट केस में एंड करके किया था, पता नहीं करेंगे.
एक मिनट रुकिए, मैं देख लेता हूँ. Data and select cases, condition, salary is, I'm just going to, salary is greater than this and salary is less than this. I'm just changing the formula because, and place one more thing here, this bracket, because of the precedence or the hierarchy. One complete condition is in the bracket. And I'm just checking that, is this fine or not? Okay. Now it's fine. 680 has been cutted. You can see that 680 has been now not included, and nothing is the below the lower fence, but above the upper fence we have only one number, that is 680. So by that formula, that number is cutted, and now you can check, analyze, descriptive, explore. And salary variable, and okay.
Oh, sir.
Now you can see that the number which was the outlier is not in the output. So that number exists in my data file, but is not playing a part in calculation. G, what your question is? Can ask.
सर जब असाइनमेंट कर रहे थे ना, तो इसका आइडिया नहीं था, मतलब आपने बताया था लेकिन उसको करना नहीं आ रहा था, तो थोड़ा इंटरनेट से हेल्प ली थी. तो इंटरनेट कहता था कि जेड टेस्ट निकालो इन सब के, और जेड टेस्ट में 2.6 और नेगेटिव 2.6 से जो वैल्यूज एक्सीड कर रही हैं उन वैल्यूज को हटा दो. तो ये सही है या
नहीं, ये भी सही है. यू कैन यूज दैट कि ये आपकी जेड से वो जेड स्कोर्स में ले आता है डेटा को, और फिर वो -3.4, क्योंकि यू सी इन द normal table the data is in between -3.4 and +3.4. So all the z values lies if they are not outlier in the range. So that is also a correct.
Okay, सर जो मतलब मैंने जो देखा था उसमें 2.6 और -2.6 था, तो मैंने उससे कर दिया था. खैर सर 3.4 is सही. ठीक है, थैंक यू.
Any other question if someone has? You have to sort the data, and after sorting you can see that all of the numbers which are the odd numbers, like we have a $sign or we have a negative number, or not a number is a character, so you can remove them that rows manually, because after sorting, all of such numbers which are not numbers will be accumulated either at the top or at the bottom. You can remove that rows manually. How can you remove the specific rows? Just click on that specific rows and like this. I have just chosen 3 or 4 rows and place clear button. Just place a clear button. So when you press the clear button, to the data which we have selected in the rows, that rows will be eliminated from the data file. So after sorting, you have all odd observations will be accumulated at either side, and similarly, the extreme numbers can also be eliminated manually by sorting. So just click on the data and sort option. This is the sort cases. Can you see the screen, sort cases?
Yes, sir.
Yes, sir.
Click the sort cases and salary variable has been selected, ascending or descending, and save to a file. If you want to save the sorted data into a separate file, so you can place the save to the file, otherwise just click OK. So now the data is sorted and you can see that 20, 31, 40, 40 and the higher numbers we have at the bottom of the data file. So now you can remove whatever you want to. Suppose I want to remove that bottom numbers, to just remove them. So this is another way to do that. Otherwise, if you are not able to cover that things, so you can take the data file into the Excel or in Power BI. That will be considered into the next part, Power BI. So we'll take the data into the Power BI or in Excel, and we implement some data modeling into Microsoft Excel or Microsoft Power BI, because SPSS is not basically helpful for data modeling. It is helpful for statistical modeling. So data cleaning and data is available here, but quite difficult to arrange or uh, apply the data model in SPSS. So better is put the data model into the another software and then place the data here in SPSS, right? I am going to take the more questions from the audience.
Sir, one question.
Yes.
सर नॉर्मेलिटी चेक करने के दो तीन तरीके होते हैं. एक तो आप जो है वो हिस्टोग्राम से देख लेते हैं, दूसरा जो है वो कॉस्मोग्राफ और उससे देख लेते हैं, और तीसरा जो होता है वो बॉक्स डॉट से भी देख सकते हैं. तो हम लोग को अलग अलग उसमें आंसर्स करने, क्योंकि कभी कभी ना डिस्क्रिपेंसीज आ रही होती हैं, अक्सर ही डिस्क्रिपेंसीज आ रही होती हैं कि हम हिस्टोग्राम देखते हैं तो उसमें नॉर्मल शो हो रहा होता है, लेकिन जो है वो सिग्निफिकेंस जो है वो 0 आ रही होती है. तो फिर हम दोनों को अलग अलग लिखे, जैसे असाइनमेंट में भी आपने पूछा था.
देखिए, significance is a quantitative and we trust on the quantitative methods. These are the visualizations, histogram, box plot, or stem and leaf, or PP plots. These are all visualizations, and this is significant test. The tests are more reliable because it is based on the quantitative procedures. So we generally trust on the test. But if we have a larger sample size, n is greater than equal to 30, then still if there are some non-normality in the data, we can proceed because of the large sample size. So in most of the procedure that we are going to implement have two conditions. Either the data is normal, either population is normal, or we have a large data size, sample size, or n greater than 30. Any of the two conditions is fulfilled, then still if the data size is large, we apply the PP plot and other things just to check outliers. So that was not necessary to read for the normality, that is needed for outlier or some other things in the data set. So that is basically the procedure that we generally use.
राइट सर. अच्छा सर, एक और क्वेश्चन. सर जब हम लोग असाइनमेंट सॉल्व कर रहे थे मैं, तो उसमें कुछ नॉमिनल वैल्यूज थी, जैसे रेस थी 10 ना. तो सर उसमें भी मैंने ना जैसे हिस्टोग्राम वगैरह बना लिया था, तो उसमें भी आउटलायर्स आ रहे थे. तो एक तो मैं ये पूछना चाह रहा हूँ कि एक तो ये मेरी गलती थी ना कि मैंने उस वैल्यू का भी हिस्टोग्राम बनाया, या फिर इस तरह होता है, क्योंकि 1 और 0 वैल्यूज में भी आउटलायर्स आ रहे थे, तो 1 और 2 वैल्यूज में जैसे, तो समझ नहीं आ रहा था।
कैन यू रिपीट योर क्वेश्चन?
ठीक, हाँ पूछो आप पूछो यार, मैं बहुत पूछूं।
सर इस डेटा के ऊपर कोई ट्रांसफॉर्मेशन लगा सकते हैं अभी क्या?
हाँ, लगा सकते हैं, बिल्कुल। मैं समझा देता हूँ अभी ट्रांसफॉर्मेशन क्या होती है। और ये सवाल किसने, नवेद ने किया है?
जी सर।
ठीक है, मैं 1 मिनट अटेंडेंस शीट की एक पिक्चर ले लूँ इस वक्त, ताकि मुझे याद रहे कि आज की ट्यूटोरियल में कौन लोग फिजिकली मौजूद थे। अच्छा, नाउ कम टू द पॉइंट कि जी हम इस पे क्या अप्लाई करना था नवेद?
ट्रांसफॉर्मेशन।
ट्रांसफॉर्मेशन, ठीक है। अच्छा देखिए, ट्रांसफॉर्मेशन हम करते हैं इसमें पहले तो जस्ट क्लिक ऑन द transform and compute variable. Here you have to apply log salary. The formula, this is the new variable, and in this variable you have to select a new variable. I use a name LG before the variable salary. You cannot place the spaces here. Now on the right side you have to place functions. The functions are available here. Which type of function we have? Arithmetic function and log. If you want to take square root transformation, the second option is that. The log transformation I'm taking. Click OK. Now we have another variable into my data file, and that variable is logarithm of that numbers, right? So now you can see the logarithm of the numbers, and I'm placing analyze, descriptive, explore, and now instead of salary, I'm going to use the log salary. Log salary is chosen, and okay. Now log salary and stem and leaf. You can see that the graph is better, but still the outlier is there. Now,
डिस्प्ले दिखा देना, आउटपुट दिखा देना।
okay.
So your screen is stuck.
Yes, okay. 58 is still there, but the graph is better than before, because earlier the graph was this. This was the graph, but now the graph of the log salary is a better graph, but that number is also be there. Where is the p-values? I think p-values are not here. I'm just applying that explore again, and plot segment, normality plot with the log salary, and removing that, continue, okay. Now you can see in the output box, one Kolmogorov is saying what? Kolmogorov is LG salary. The variable is not salary, the variable is LG salary. And Kolmogorov is indicating that 0.09 means it is insignificant, means it is not normal. But what Shapiro is indicating, it is not normal.
It is normal.
It is normal by Kolmogorov, it is not normal by Shapiro. So still this is one outlier, but I demonstrated how the transformation is to be implemented. So just click on.
Sir, what other functions can we use?
You can use the several functions what I suggested in the file, depending on the nature of skewness. Square root transformation by sqrt function. Can you see the screen on which I am writing?
Yes sir.
Okay,
Yes,
log
sir.
transformation LG10, LG10, not LOG. LG10 is a function available in SPSS, and sometimes we use the reciprocal transformation. The reciprocal transformation can be done by 1 upon salary. Just implement a formula 1 upon salary. There is no function over there, but you can apply that manually. While tangent, sine, cosine, all these functions are available, you can use any of the functions. The main strategy is, if you have a larger number into, sometimes we use a square transformation instead of a square root. square transformation. Square transformation is making the whole square of the number. So that is also a transformation. If we have a smaller number, take the square of them so that it will be bigger canvas. If we have a larger number, take a square root of that so that it will be the smaller in canvas. So that is the way and the strategy to use in the transformations. I am just specifying one file which will be helpful for you with respect to judging or analyzing the transformation. So where that file I am just referring, you have to click on my course site.
व्यू चेंज कर देना.
मैं कर देता हूँ. This is my course site. Here we have a course DASPSS. DASPSS means data analysis using SPSS. So this is purely the SPSS based course. And here I'm identifying the two files. One is the fourth one. That is graph and transformation. This is one complete presentation, graph and transformation. Histogram, how using the graph to describe the explorer function. Line graph, scatter plot, box plot, and that is implemented normality. So you can read this complete file because this file help you how to check the normality and how to take the decisions about the transformations. This is the topic, transformation. Can you see the PPT slide?
Yes, sir.
Transformation. So here are some suggestions. That is very important slide. Square root transformation. If we have a lighter skewness, then try to apply the square root transformation. If the skewness is slightly high, like from the first one, to use the log transformation. So if we have a light skewness, right skewness, the square root. If we have a high skewness, right side, log transformation. Inverse transformation or reciprocal transformation. If we have an extreme right skewed, take reciprocal. So these three very simple transformations are very slight right skewed, log, some high right skewed, log, and extreme right skewed, take reciprocal. So these are the three very important suggestions you can have on this slide. Take a snapshot of this slide because this slide will help you to take the decision about the transformations. And as well as if we have a negative skewness like this, so the same square root will be used, but k minus old variable. Old variable was what? Old variable was salary variable. The square root of k minus. What is k? K is the largest possible value, highest value in the data plus 1. So you have to take that value of k from the descriptive table because descriptive table will show the minima and maxima of the data. So take the maximum number in the salary variable, then plus 1 is the value of k, and they apply a formula square root of k minus salary. Is this okay to all of you? Similarly, if we have a very high negative skewness, to log. If we have an extreme left skewness, to reciprocal. So in the first three graphs, take the direct square root, log, and reciprocal. In the negative skewness, k minus, and k minus. Apply the same three formulas by the k minus. Is this okay to all of you?
यस सर. अच्छा ये बताएं सर, के जो है लार्जेस्ट पॉसिबल वैल्यू आउटलायर निकालने के बाद है या फिर
के अगर आपने आउटलायर निकाल दिया तो उसके बाद जो भी हाईएस्ट वैल्यू है उसको रख लें आप. ठीक है.
ठीक है सर. ठीक.